A single strand of hair, a microscopic fiber from a sweater, a speck of soil on a shoe sole. To the untrained eye, these are nothing, invisible, insignificant, easily overlooked. But to a forensic investigator, these microscopic traces can be the single piece of evidence that separates a guilty verdict from a wrongful acquittal. In countless criminal cases around the world, it was not a confession, not an eyewitness, but a fragment of glass or a single fiber that placed the suspect at the scene of a crime or proved their innocence. Welcome back to Forensic Expert Alliance of Bangladesh. In today's episode, we're going to explore one of the most fascinating and scientifically rigorous branches of forensic science, trace evidence. We will examine what it is, the scientific principle that governs it, the different categories investigators look for, and how this evidence travels from a crime scene to a courtroom verdict. If you are a medical student, a forensic science enthusiast, or simply curious about how real criminal investigations work, this video's for you. Let's begin. Trace evidence refers to small, often microscopic materials that are transferred between a victim, a suspect, and the crime scene during the commission of a crime. Unlike fingerprints or DNA, trace evidence is typically minute in quantity. A few fibers, a handful of soil particles, a flake of paint. Yet, it can carry enormous evidentiary weight. These materials are classified as trace because they are frequently transferred in trace amounts during physical contact. A struggle between an assailant and victim, a vehicle striking a pedestrian, or even simply walking through a location can result in the exchange of these microscopic materials. The significance of trace evidence lies not in its size, but in what it can establish: physical contact between a suspect and a victim, presence at a specific location, or the use of a particular weapon or tool. In many cases, trace evidence becomes the connecting thread that links seemingly unrelated facts into a coherent narrative of the crime. The entire discipline of trace evidence analysis is built upon a foundational concept known as Locard's exchange principle, formulated by French forensic scientist Dr. Edmond Locard in the early 20th century. The principle states, in essence, that every contact leaves a trace. When two objects or individuals come into contact, there is always a mutual exchange of material between them. A criminal entering a crime scene will both leave something behind and take something away, even if that exchange is invisible to the naked eye. This single principle transformed criminal investigation from a discipline reliant on testimony and circumstantial reasoning into a science grounded in physical evidence. It is the theoretical backbone that justifies why investigators meticulously search crime scenes for fibers, hairs, and particles, because according to Locard, that evidence must exist somewhere, however small. Understanding this principle is essential because it shapes every protocol forensic teams follow during evidence collection, search strategy, and laboratory analysis. Trace evidence encompasses a wide range of material categories. Let's examine the most significant types encountered in criminal investigations. Hair and fibers. Human and animal hair can reveal information about race, body region of origin, and sometimes DNA profile if the root is intact. Textile fibers, whether natural like cotton and wool or synthetic like polyester and nylon, can be matched to specific clothing items, carpets, or upholstery, helping place a suspect at a scene or in contact with a victim. Soil and geological material. Soil composition varies significantly between locations due to mineral content, organic matter, and regional geology. Soil found on a suspect's shoes or vehicle can be compared to samples from a crime scene to establish geographic association. Glass fragments. When glass breaks, it can transfer microscopic fragments onto a person's clothing, hair, or skin. Refractive index analysis allows forensic scientists to compare these fragments to glass from a broken window or windshield, often with remarkable precision. Paint evidence. Particularly relevant in hit-and-run investigations, paint chip analysis examines the layered structure and chemical composition of automotive paint to match a fragment found at a scene to a specific vehicle make and model. Gunshot residue. Microscopic particles released during the discharge of a firearm can be detected on the shooter's hands or clothing, providing critical evidence in firearm-related cases. Botanical evidence. Pollen, seeds, and plant fragments can establish whether a person or object was present in a specific environment, given the highly localized distribution of certain plant species. Each of these categories requires specialized collection and analytical techniques, which brings us to the next critical stage of the process. The evidentiary value of trace evidence depends entirely on how meticulously it is collected, documented, and preserved. A single error in protocol can render otherwise powerful evidence inadmissible in court. Crime scene investigators follow a systematic search pattern, grid, spiral, or zone searches to ensure no area is overlooked. Evidence is collected using specialized tools, tweezers and forceps for visible particles, adhesive lifts for fibers and hairs, and vacuum sweeping with specialized filters for diffuse trace materials across larger surfaces. Each piece of evidence has to be individually packaged to prevent cross-contamination. Paper bindles, sealed envelopes, and labeled containers are standard practice, with every item documented through photography before collection. Perhaps most critical is the chain of custody, an unbroken, documented record of every individual who has handled the evidence from the moment of collection through laboratory analysis to courtroom presentation. Any gap in this chain can be exploited by defense counsel to challenge the evidence's integrity, potentially undermining an otherwise solid case. Once trace evidence reaches the forensic laboratory, scientists employ a range of analytical instruments to extract maximum information. Microscopy remains the foundational tool. Comparison microscopes allow side-by-side examination of questioned and known samples, particularly for hair and fiber analysis. Spectroscopy techniques, including Fourier transform infrared spectroscopy and Raman spectroscopy, identify the chemical composition of paint, fibers, and other materials at a molecular level. Scanning electron microscopy with energy dispersive X-ray spectroscopy, commonly abbreviated SEM-EDS, provides detailed elemental analysis, particularly valuable for gunshot residue and soil mineral composition. Refractive index measurement is the standard technique for glass comparison, allowing precise matching between fragments based on how light bends through the material. These techniques, often used in combination, allow forensic scientists to move beyond simple visual comparison towards statistically defensible conclusions about the probability of a shared origin between evidence samples. Trace evidence rarely solves a case in isolation. Its true power lies in corroboration. When combined with witness testimony, digital evidence, and DNA analysis, trace evidence can construct an irrefutable narrative that withstands rigorous courtroom scrutiny. Historically, trace evidence has played a decisive role in countless investigations, helping to place suspects at crime scenes, link weapons to victims, and in some cases, exonerate the wrongly accused by demonstrating their absence from a scene. In the courtroom, forensic experts must testify not only to their findings, but to the scientific validity of their methods. This is why standardized protocols, accredited laboratories, and rigorous peer review are essential. A forensic conclusion is only as strong as the scientific process behind it. For Bangladesh's evolving forensic and legal infrastructure, strengthening trace evidence laboratories and training represents a critical investment in the integrity of criminal justice. Trace evidence reminds us of a simple but powerful truth in forensic science. No crime is truly invisible. Every contact, every movement, every interaction leaves something behind, and that is the forensic expert's task to find it, interpret it, and let it speak the truth. Thank you for watching this episode of Forensic Expert Alliance of Bangladesh. If you found this content valuable, please subscribe and share this video with fellow students and professionals interested in forensic science. Leave your questions in the comments and we'll address them in future episodes. Until next time, stay curious about the science of justice.